Our last presenter is Nick Bond, who is the state climatologist. He is a research scientist at the Joint Institute for the Study of Atmosphere and Ocean, and one of his areas of interest is the effects of climate variability and change on the North Pacific Ocean, and he is here to talk to us about the outlook for this winter.
Hey, thank you. Yeah, thanks. Hey, thank you. So how many of you were at this event last year? Wow, very good. You may recognize this cartoon, the mythical beast that was liable to influence our weather last winter and so forth. So this summer, it was looking like another creature might be making a difference here. And whether that's still the case or not, I guess you're going to have to stick around to the bitter end to find out and all that. So what I want to do today, actually, is just talk about what we're anticipating for the winter ahead. And I am your state climatologist, and this is work that I do with the assistant state climatologist, and I have to admit I see him in the foreground here. I've been comparing notes with Mark Moore, the dean of avalanche forecasting around here. So, Emeritus, what's your present position? Right. Yeah. So, all right, I would like to take first a chance to briefly review last winter, and in particular, maybe this was a bit of a surprise to folks. And in particular, what was noteworthy about it was just how wet it was in December, and how much snow we got in the mountains. There was records at Snowfall Pass. I-90 was closed for a while and that sort of thing. And so, you know, wait a minute, I thought El Nino kind of warm and dry, right? Well, not really. The warm signal, it was a little bit warmer than normal, quite a bit warmer than normal, and that is something that we systematically see with El Nino, especially strong ones. The dry versus wet, that's much less certainty in that part of the forecast, and I'll talk a little bit more about that. And so again, you know, what did El Nino have to do with it? This is a cartoon that I didn't put together, but if you probably can't see the wording from the back, but that red blob over us, the top chart having to do with El Nino, indicates warmer than normal conditions for us. It doesn't really say anything about the amount of precipitation. And during La Nina at the bottom, we tend to get a different kind of storm track, and that's actually very favorable for snow in our mountain regions here. So again, in the idea, you know, kind of post-mortems and so forth, how did we do last winter? Well, the atmosphere, to a large extent, actually behaved itself and did things that it has done in previous El Nino winters. The chart on the top there shows about 3 kilometers up in the atmosphere, the steering level for it, what the pressure pattern is, with the purple color showing where there's lower than normal pressure, the greens and reds where there's higher than normal pressure. The one at the top shows the average of the previous strong El Ninos, and the one at the bottom shows what actually happened last winter, and this is for November through February, but different combinations of months give the same thing. And so basically on the large scale, it was very similar to what we've seen before, but of course the devil's in the details, and right near the West Coast, a lot more of the storms came into our part of the US West Coast versus California. So what's happening right now, right here, this map on the left shows the sea surface temperature anomalies earlier this month, the temperatures relative to normal, but these are warmer than normal, the blues colder than normal. You can see kind of some patchy cold weather right along the tropical Pacific, central to eastern tropical Pacific. Here's a time series going back to 1982 or so of the temperatures in this region going up and down. There's the last year's El Nino. And right now, it's a little bit cooler than normal. It's not officially, well, it's kind of ambiguous whether it's in La Nina state or not, or just kind of more near normal. What our models are suggesting is here. If you first look at the upper right here, there's various models that are used to forecast that phenomenon. And it's a big deal because it's so important to the seasonal weather in various parts of the world, is that there's, most of them keep it a little bit on the cold side. Some make it colder, some warm it up, some. But basically borderline La Nina conditions through the remainder of this winter and into 2017. This is kind of encapsulated with this plot here that shows the odds, the probability here, 0 to 100% of either La Nina in the blue bar, neutral conditions in the green bar, or El Nino, which through fall, middle of winter, end of winter, and into next year. And so the idea there is there's roughly equal chances of it being kind of a borderline La Nina or in the neutral range. All right. When you actually look at what happened in previous winters like that, I've just gone back, and this is kind of the ones that I thought were the closest analogs to the one we're looking at, and in that aspect of the climate system, for, in this case, November through February, very much near normal temperatures when you take an average of these previous 5 winters, and a little bit on the wet side. Conceivably, in eastern Washington, the kind of west slopes of the Rockies, maybe a little bit cooler than normal. This kind of information is being used by the official forecast from NOAA, from the Climate Prediction Center. I'm not going to go through all the sort of tools and information they use to create those forecasts, but a lot of it is what they're relying on in this case is historical relationships based on this El Nino, La Nina sort of cycle. And one thing I do want to emphasize is that the forecast skill is actually greatest at the end of winter. And one thing that's definitely clear is that the temperature forecasts tend to be more skillful than the precipitation forecasts. And so what are they saying? These are the official forecasts. You should pay attention to them, maybe not me. Maybe I shouldn't say that. But anyway, this is what they're having for their forecasting, kind of a 3-tier system where there's either kind of in the below normal range, above normal range, or equal chances of kind of near normal, below normal, or above normal. And so for the early part of the winter coming up, November through January, it has most of the west and central U.S. warmer than normal. Right up here in our neck of the woods, maybe a little bit, not much of a signal one way or another. As you go into late winter here, and I realize there's some overlap here, but in January through March, mostly based on the connections in the previous history with La Nina, it has us a little bit on the cold side. Good for mountain snowpack, and good for a lot of things as far as I'm concerned. I'm not so sure that I really buy this, and I'm going to show you a couple of reasons why I think there may be some competing effects that would tilt the odds to something more near normal. In terms of precipitation, though, these are the official forecasts from the Climate Prediction Center have us slightly above odds of wetter than normal in the early part of the winter, and a little bit better odds there in the later part of the winter. And I guess I don't have a real quarrel with that, with the realization just precip forecasts on a seasonal timescale are just really tough. Okay. And one of the reasons they're really tough is that you get conflicting information. And here, these are just thumbnails of the actual precipitation forecast. This is for November through January for what it's worth, from various models and that are considered by the seasonal forecasters. And it's kind of like 6 out of 7 dentists recommend you chew sugarless gum or something like that. Well, 5 out of 8 of these models have us definitely on the wet side, a couple maybe on the near normal, but one has us definitely dry. And we can't say, oh, we can't dismiss this one out of hand. Oops, look at that. Wow, sorry about that. A little heavy on the, right. Yeah, so anyway, there's a lot of uncertainty in precipitation. And that is actually reflected in some of the statistics that have been put together over the last 15 years, where the hotter the colors here, the more skill there is. These are how good the temperature forecasts are. And the western U.S., we actually do better than the other parts of the country. And this is the precipitation forecast, very marginally positive skill. All right. So one thing, just as kind of an aside, just a new tool that's come out of the Climate Prediction Center is a 3 to 4 week forecast. And it comes out once a week on Friday. This is actually one made, 10 days ago or so. And it's just kind of a map for the 3 to 4 week period. And this is something, there's much greater and greater interest in trying to bridge that gap between the kind of weather forecasts out a couple of weeks and then these seasonal ones. And so they're experimental, but I would, if you're interested in this sort of thing, encourage you to, if you Google it, you can find it, to kind of check them out. All right. So one of the reasons that I think we might be kind of leaning a little bit more toward normal temperatures than on the cool side, especially at the end of the winter, is because of what's happening in the waters off our coast. Right now, or a couple of weeks ago, there was, the water is warmer than normal off our coast. And I've done some very simple-minded stuff where just comparing the temperatures in Washington State for the winter, November through March in this case, following what looking at what the temperatures out here in the ocean are in October. And when you do that, make that sort of comparison, there's a relationship. It's not really tight, but there is a tendency when there's cold water out there. We haven't really had a very warm winter, and we haven't had a really cold winter when the water out there is warm. October isn't done yet, but we're going to be kind of in this range probably, and so that does stack the deck for a little bit warmer than normal. Another thing that's happening is maybe a concept you've heard about, and that's global warming, right? And here I just have a time series for the winter for the Puget Sound region where we've had a lot of stations going into it. This goes back to 1895. And you see year-to-year variations and so forth, but there is this inexorable upward trend in the temperatures. And what I'm struck by from this, this plot is that in years past, here in the 30s, we had some warm winters occasionally. The one of 14-15 was the record setter. Woohoo, we're #1, right? Last winter not as warm. But what I'm struck by with this series is that we simply haven't, for a few decades, gotten some of the cold winters that we had in the distant past. This doesn't mean that it can't happen, but it just, it's been a long time since we've had some of these really bitterly cold winters. That's also reflected here at Snoqualmie Pass, the total amount of snowfall in the winter, where that's a place very sensitive to temperature, of course. And this time series goes from 1950 through the present winter. I've kind of color-coded the winters with this El Nino and La Nina to kind of impress upon you how La Nina is good for snow in our mountains. And that last winter actually was a little higher than anticipated, just given most of the El Nino winters are kind of in here, but it was obviously so much better than the disaster of 14-15. And so that one really stands out. All right, so yeah, we're getting a little bit less snow than we used to in the middle of the 20th century. In a similar fashion here, the Snoqualmie River that is sensitive to whether it's rain or snow in the Central Cascades, we see that there's a tendency for the biggest flood of the year to be greater in recent years. And it doesn't mean that every year has a monster flood, but the biggest floods are bigger than they used to be. All right. So, Western Washington lowland snow, it's no good to, this is a big deal for the population, of course, and they are so doing another one of these little color code things for reasons that escape me right at the moment. I just went back to 1980. In part, actually, I know why I did that. It's because our climate is different than it used to be in the middle of the 20th century, and so I thought it was more relevant just to look at the last few decades. And it wasn't like every year, and this is at SeaTac, the total amount of snowfall, every year back then had lots of snow, and in fact, El Nino winters are basically disasters if you want to, build a snowman in your front yard or something. But there were many of the years did have a significant amount, and that has not been the case so much in recent years, with a notable exception in December 2008, right? And so that's still possible, but it's still, it's all a matter of the kind of odds and probability, and that's what's happening to us. All right, so I'd like to, just last few things I'd like to talk about is a kind of an idea about the kind of little bit more subseasonal scales and what kind of weather we can anticipate for the winter ahead. And one of the examples of a year that I think is a ways back, but it's still, I think, relevant, is 1983-84. That was a year following a strong El Nino. The tropical Pacific was on the cool side, not a full-fledged La Nina event. And so what I've plotted here on this top plot is temperature at Stampede Pass. This is on the bottom plot is the accumulated precipitation, this green trace. So getting back to the temperature, here it's the day-to-day variations in temperature, max and min. This gold band is the normal max and min, and then the records are shown with these red and blue lines. And one of the things I want to get across is we had a pretty intense cold air outbreak in late 1983. It actually produced one of the strongest Enumclaw windstorms, very strong east winds, if you've ever been familiar with that situation. During the actual coldest air, there wasn't much precip, but right as we warmed up, there was some snow in the lowlands and quite a bit in the mountains. And there was another kind of cold air outbreak there in, let's see, early February, I think it was. And so, but then also some periods of warmer weather with some rains and so forth. And so, if anything, maybe a little bit more variability than usual within the season. So to kind of summarize, wow, this one kind of came out a little bit, not very crisp, let's say, but what I have put together here is for weak La Nina conditions, how the snow depth from the middle of November through May 1 has on average built up. Here, this top trace is Mount Baker. The black trace is Stevens Pass, and the blue trace is Snoqualmie Pass. And for the most part, Baker does really well. And what tends to happen in these situations is that there's a pretty good growth in the snowpack kind of late in the winter season. And I think that's better illustrated with 3 different examples in the past of years kind of like this one. 83, 84, 95, 96, and to a certain extent, 2013, 2014. Maybe this one isn't quite the same, but, and here, again, the same 3 places, Baker, Stevens, and Snoqualmie, where there's some decent snow most years, early in the season, and then a kind of rain event, a warm event, melted and compacted a lot of it, but then good growth in the snowpack late in the season. And that was especially the case in 2014, where going into February, it was looking like, wow, we're going to have enough water for the summer and so forth. But it actually started coming down big time. There was, of course, the also landslide, tragically, that was very heavy precipitation was certainly a factor in. But the snowpack really built up late in the season that year. All right. So I haven't had a chance to talk too much about the kind of individual events, but we all, I can't resist kind of saying a little bit of something about not just kind of snowfall, but some of the other things that are, important around here. Floods. We have floods every winter. And we're set up, especially in some of the basins, with a higher odds of major to severe floods. And so that's something that is a pretty good bet. Windstorms, wow, that's a real crapshoot. And of course, we dodged a bullet a week ago. I'm still getting over the blown forecast and all that. And I encourage you not to talk to me about that, because I'm still a little upset. But in the present sort of mean state of the climate system with the weak La Nina and that sort of thing, it maybe is a little bit more likely we'll get a windstorm, but it's a very noisy sort of data set. Cold air outbreaks, certainly better odds than the last 2 years. And I'm quite confident of that. The El Nino, well, in 2014-15, it was just so warm, that was just way out there. The El Nino really stacks the deck against those. We don't have that sort of unfair situation here. And so I think there's good odds that we'll get at least some cold air outbreaks. We just don't see them as severe as we used to in years past. Doesn't mean it can't happen, but I'm sure we're going to get something of that sort. Fog air pollution, let's not talk about that. But end of season snowpack. Here I've written probably slightly less than the long-term average. Well, what do you mean by that? And I'm thinking, if you go back to the recorded past, back to the 30s or something like that, relative to the last 10 or 20 years, it's probably going to be something comparable to the average there, or maybe even slightly above. It's just that, again, because the trend is downward, it's probably less than the really long-term average. But it's almost a sure bet it's going to be better than 2 years ago. All right. So just to summarize, want to leave this chart up there for the country as a whole of what we're expecting for the winter here. And yeah, so at least we're, not in this maybe. But all kidding aside, I do encourage you to contact the climate office if you have questions or just you want to talk to us, and especially encourage you to talk to Karen. No, I'm not kidding. You can call me too, but I wouldn't put up this slide unless I wanted, to kind of hear from you. And I've gotten ideas about things to look at, and it just it beats answering emails. So, thanks.
Who would like to ask a question of the state climatologist?
Oh, okay, shoot.
The mic is headed towards. Yeah.
Oh.
The question was, what happened to the blog?
Well, yeah, careful what you ask for. And that's what I'm referring to. This is basically the blob, and so it kind of reared its ugly head again this summer. Just in the last week or so, it's moderated some. I don't have the slide with me, but the warm water has now extended down to 300 meters depth or so. And so there's a tremendous amount of extra heat there. And it's going to take a while until that moderates. And so that's one of the reasons that I think, because our prevailing winds are from the west, one of the reasons why, even with this borderline La Nina, we're going to be more in the middle of the range in terms of temperatures. Any other questions? Yo, Mark.
I was curious whether or not you felt the warm blob had an effect on the track of the remnants of Typhoon Songa.
Yeah. So the question was for the storm that wasn't a storm last weekend that tracked a little bit further west than the model's forecast. I'm not aware of any sort of serious work that has been done on, in terms of trying to tease out just what went right or wrong depending on your point of view. But there, for the most part, our wind patterns and pressure patterns don't seem to be so sensitive to what the ocean is doing right off our coast. It does, if the water is warm, it kind of warms and humidifies the air. And so it does something to the thermodynamics, but it doesn't really change the wind so much. So I'd be surprised if we can blame the blob for that. But it's far from settled. Anybody else?
Let's take one more question.
Yeah, that's cool. Yeah, so, no, hey, no hard feelings. And so, again, hopefully you guys will be back next year. Who knows if I'm going to be invited back. But we can compare notes and see how well my forecasts were. So, thanks.